Morning, Tehmina Khan is here in TKMaths is Fun. In today's video, I will explain to you a concept of volume of a solid, which is a part of the syllabus of A-Level Mathematics P1. And the code is 9709. I have picked up a question from June 17, variant 1-2. It's question number 6. So other than explanation, I will give you a little background of what volume of solid means as well, not just the solution. So before beginning, you can see on the top my blog address and my website address. Do visit it. You will find a lot of information related to maths topic and explanation, which will be helpful in your learning process. So let's begin. First of all, we will see what is volume of revolution or volume of a solid. Now, imagine this figure, right? Let me hide the rest so that you can focus on one concept only. So if this figure is given to you and this area is shaded and you are asked to rotate it around x-axis, right? Rotate it around x-axis. So what will you get? Will you get this shape? Because you are revolving it around x-axis. Now, when we say volume of solids, basically we know how to calculate volume of particular shapes for which we know the formula. But there are certain shapes and we don't know the formula, so we integrate it because integration gave us the volume, help us to find out the volume within the given limits. And we will see that today. So in the course, we have revolving around x-axis, revolving around y-axis. So we will see all those concepts. I have taken one example only in this video. Okay, so let's see here in this case, first of all. Rotation through 360 degree means complete rotation about the x-axis. So this is your picture. This is the shaded area and you are rotating it around x-axis. So what shape will you get? This shape you will get. It is not important to know which shape because we don't need it, but this is just for the visual understanding basically, that you understand what we are trying to do. So we will find out the volume of this shape with the help of integration and by taking the limits here. And we will see the procedure in a while. Similarly, if this area is given to you and the limits are given from here to here, then what will be the shape you will get? And you are trying to find out the volume of what? So this type of shape you are getting, and you're trying to find out the volume of this solid, right? Let's see if we are revolving it around our y-axis. So now, if this is the shape and this is the shaded area, right? And now you are revolving it around y-axis. So you are revolving it like this. So what type of shape you will get? This type of shape you will get. And you will find out the volume of it. So we will see when we have to revolve around the y-axis, then how do we calculate it? In this video, I have not explained it, but in the next video I will, right? Then we need to change, make a change in the equation. Also, we need to make x a subject. So I will teach you all that later. So similarly, if you look at this equation, this figure, and suppose this is the shaded region, right? And you are revolving it around x-axis here, y-axis here. So what shape you will get? This is the shape you will get. And you will find out the volume of this shape, this solid. So again, when we rotate about the y-axis 360 degree, what is the technique? How do we deal the equation? How do we take the limit? That we will cover in the next video. So these are the formula here. Basically, it is this formula which you have to remember. Just give me a second. When you are revolving around the x-axis, you remember this shape. What is the formula? Pi y square dx. And limits are the boundaries of the shape, which I have shown you. And this x is representing here revolving around x-axis. So when we will solve, pi will go out of the integral sign because it is a constant, and y square, the function which is given to you, you will square it first and then integrate it. So we will see it in the equation now. So let's pick up this question. Now, if you see what I have explained to you right now and what I'm showing you is a little different. In all the previous Achha, by the way, I did not show you here the other formula. This was for revolving around y-axis because I thought I'll cover it in the next video. The only difference is, if you notice here in this formula and this formula, it is written here pi x square. It is written here pi y square. So the difference when you're revolving around x-axis, your function has to be y is equals to in terms of x. Sorry, let me change the mode of the pen. And when you're revolving around the y-axis, then your function has to be x is equals to in terms of y. So you have to change your function, right? Okay. So what I have shown you here in this picture, the area was touching the x-axis. Can you notice? Area is touching the x-axis and it is under the curve. Under the curve and the x-axis. And these are the shapes we are getting. Now the question I'm solving here, which is from past paper June 17, the shaded area is between a curve and a straight line. It is not touching the x-axis. Then how we will calculate it? Boundary, so I can see because question is saying revolve around the x-axis. So this solid shape is revolving around the x-axis like this, right? And what are the limits or the boundaries? These are the boundaries basically for the question. So my limits will be 1 to 4. So limits are not a problem, but the thing is, how will I do this? Excuse me. So now if you see here, actually, I'm giving you a visual picture of it. When you will revolve it around it, right, around the x-axis, this is the shape you will get. This is a hollow part inside it. In the previous diagrams and the previous solid figures, they were solid. It was not hollow. But this is hollow here. You know, we have glasses of different shape, which have like shape from here, thick and thin. So the inside is hollow in which you contain water. So this type of solid you will get, and you have to find out the volume of this solid, basically the material you have used. So what is the volume of it? Now, if I connect the procedure here with your understanding of O-level maths, you have done questions of this type, where volume of a cylinder was asked, where this blue portion is actually hollow, it is out. The radius of it is given to you. And the volume of the outer radius of a circle is given to you. So what you used to do, if you remember, volume of a cylinder is pi r square, outer one, okay, outer one, minus pi r square, sorry, h. And you subtract the two to find out the volume of the remaining portion, if you remember it, right? So this is, we do in O-level maths or in other boards also, but at the simple maths. So this is how we want to find out the volume of a cylinder of the remaining portion. Exactly the same logic we will apply here now. Now let's see. I have covered it with shapes. If you see here around this line, let me highlight it again. This is straight line. If this straight line is there, from 1 to 4 only, right? From 1 to 4 only. Let me draw till here only. And this is revolving around the x-axis. Then you will get what type of shape? This type of shape. And this will all be solid colored. But if you are revolving around this shape, which is here, this boundary, right? And this green portion you move around x-axis, you will get this type of thing, solid. So if you subtract the volume of this minus volume of this, then you will get your shape, right? So this is the volume we have to find out. So the concept we will apply here is volume of rotating this line around the x-axis, then volume of the shape formed by rotating this curve around the x-axis and subtracting 2. And the logic behind it is exactly what I have explained to you here, right? So now I will apply the formula for this line and then for this curve, right? So let's see here. So the formula for the volume of a solid revolving around the x-axis is pi y squared dx. Now, first of all, I will apply for this line. So I have to change this equation in terms of y. It will be y 5 minus x. Because in the equation it is a square, so I have to square it. in the formula, I mean, right? So, and subtract from this curve volume, which is revolving of this. This is already given in y, so no issue. So I am doing volume is equals to pi y square dx minus volume for this curve. So I have written the two formulas here, same formula, but the equation of y is changed according to this one and according to this one, exactly same thing. You can solve, I have solved it in both ways. Here I have shown you that I'm taking pi common out and I'm subtracting these two squares. Can you notice here? I will tell you the common mistake students make. When you have to find out the area, the common mistake, when you have to find out the area, you do what? This upper curve minus lower curve. So when your students have to find this volume, they usually do upper curve minus lower curve and they square it. You can't do this. You have to do it individually, right? You have to square upper curve, which is a straight line in this case, and the lower curve. And then you are subtracting it. Okay. So now it is a simple integration. You can open it. Oh, this part I did here last time. So you expand it, you get all the terms, and then apply integration on each term here. 16 divided by x square is actually 16x power minus 2. When we integrate, we bring it in the numerator so that we can integrate it. And after integration, now you will apply the limits. Limits are 1 to 4. Sorry, I've written by mistake 0 here. It is 1 to 4. And you know integration upper limit minus lower limit. So after that, we are applying limits here. I have shown each and every step substituting the value of upper limit in x and then lower limit in x. And I got my answer 9 pi. Question, if you read, says very carefully, very explicitly, showing all the necessary working, the volume obtained. Okay, the word exact is not here, right? If the word says find the volume in the exact form, then you must have to write here n pi, sorry, 9 pi. But if it is not mentioning, then you can substitute the value of pi here and write your answer in 3 significant figure, right? And the second method, which I just mentioned here earlier, that if I don't want to open it, right, expand it, so I can apply integration on this part here separately and this part here separately. In the previous case, I basically take the common out and minus 2 functions first. So here I'm applying integration separately, and then after that I will get the same answer. So this is all about it. You can put the video on pause and try it yourself at any point. So thank you very much for watching it. In the next video, I will explain you how to find the volume of a solid revolving around the y-axis. So do share it with your friends if you like it, and do like and subscribe button and bell icon. Thank you very much. Take care. Allah Hafiz.